is we're going to take each one of these parentheses and we're going to set it equal to 0 and then solve. Okay, so we're going to take x plus 2, set it equal to 0. X minus 5, set it equal to 0. X minus 3, set it equal to 0. X plus 4, set it equal to 0. And 2x minus 5 equal to 0. Now, if there's no number that's out in the front, then what you can do is you can just switch the sign of each of these, because I'm pretty sure that's what most of y'all did. Like for this one, we would get x equals -2, x equals 5, x equals 3, x equals -4. Everybody see where I'm getting these numbers? I'm just switching the sign of the number. But on this one, we can't just do that. We've got to add 5. And then we're going to divide by 2, which will give us x equal 5's half. And you can leave it like this. So our answers are all of these. So how many solutions does this guy have? 1, 2, 3, 4, 5. So what degree polynomial would this be? Has 5 solutions. What degree polynomial will it be? A 5th degree polynomial. Okay. All right, so we got these two. Again, we're going to set them equal to 0 and then solve, right? So I'm going to subtract the 3. And then I'm going to take 2 and divide it on both sides. So that's going to give me x equals -3/2. On this one, I'm going to add 3 and then divide by 2. So x is going to equal +3/2. So how many solutions do I have? 2. What kind of polynomial is this? Has an exponent of 2, so that would be a quadratic. Okay, I know they didn't ask you that, but you should be able to make that connection. Go ahead and take a moment, try D. D is exactly like how we solved for B and A. So take a second, try that one, because I see a lot of people right now. All right, so on D, we're going to take each of these, set them equal to 0. And when we solve, we're going to subtract 5. And then we're going to divide by 2. So we're going to get x equals -5/2. The reason why I subtracted on this one is because it's added on the other side. So in order to move it to the other side, we have to do the opposite. Okay. Over here, I'm just going to subtract 1. So x is going to equal -1. How many solutions do I have? What kind of equation is this going to be? A quadratic, right? Okay. On C, we're going to do the same thing. We're going to set all of these equal to 0. Okay. Now, when I divide by 3, I'm still going to get x equals 0. So everybody see where I got that from. Okay. On the x plus 5, I'm going to subtract 5. And so x is going to equal -5. Now, here's the one that's going to give us something goofy. I'm going to subtract 2 on both sides. And then I'm going to take the square root. Say it again. When we take the square root of a negative number, what does that give us? An I, right? Okay, so this is going to give us x equals positive and negative I, and we're going to leave that square root of 2 underneath because it doesn't give us a whole number if we plugged it in. Okay, so we'll have x equals -5, x equals 0, and x equals plus and minus I square root of 2. My question to you, how many real solutions do I have in this equation? 2. I have x equals 0 and x equals -5. How many complex do I have? 2. Why is there 2? Because of the fraction. You mean this plus and minus? Okay. So because of this plus and minus right here, we have two complex solutions. So how many solutions do we have in total? 1, 2, 3, 4. So what kind of polynomial is this going to be? A quartic, right? No, sudden silence is very reassuring. Okay, so knowing how many solutions I have tells me what type of polynomial I'm going to have. Okay, I'll give you a second to finish writing that down before we start talking. Okay, so we're going to graph these, and this is from up above. We already solved all of these, so I'm going to do it pretty quickly. So we're going to have a 0 at -2, 5, 3, -4, and 5 halves. Okay, so -2 is going to be about here. 5 is going to be about here. 3 is here. -4 is here. And 5 halves. What decimal is that? What's 5 divided by 2 in decimal form? Yeah. 2.5. Okay, so it's going to be somewhere in between here and there. Sorry. We're about to. Okay, now remember how I asked you what degree polynomial this is? Okay, so how many solutions does it have? 1, 2, 3, 4, 5, right? Now, are these going to be positive or negative polynomial? Like, is this going to be a positive or negative polynomial? And how do you tell? Right, so if we multiplied all of these x's out, it would be positive because they are all positive, right? Everybody see that? All of that yellow, if I multiplied all of that mess out, I would get an x to the 5th, right? Okay, so we know that odd functions look like this or they look like this. This one is the positive version. This one is the negative version. So I know that I'm going to go from down here and start my line, okay? Now, you remember how we studied those crosses, bounces, and wiggles? Yes? All of these are going to be crosses because they have an exponent of 1. Okay, all of them are going to have crosses because they're an exponent of 1. That means that I'm going to go up, back down, up, back down, and then finish up. Not the most pretty function, but here we are. So notice how this in behavior is the same as this in behavior. That's how I know how to start my line. Okay, I'll give you a second to finish writing that down. Remember, this one is 5th degree because it has those 5 zeros, right? Over here, we're going to plot these zeros. Remember, we solved these earlier. We've got x equals 0, x equals positive negative I square root of 2, and x equals -5. Okay, so we're going to go ahead and plot 0 and -5. Now, the problem is I can't plot that complex solution, right? This complex solution right here does not lie on the x-axis. Like it doesn't touch the x-axis. Okay, that's what makes it complex, right? So when I draw my line, okay, this is going to be what type of polynomial? What degree is it? Well, we've got how many solutions? 1, 2, 3, 4, right? So we know that this is a 4th degree polynomial. And we know that even numbered degree polynomials are either like this or like this. Is this going to be positive or is it going to be negative? Well, if we take all of our x's and we multiply them together, would that be a positive number or would that be a negative number? Be positive. So we know that its in behavior is going to look like this. So we're going to start up here we see that this is a cross because it has an exponent of 1. And then we're going to cross again at 0 because it has an exponent of 1 as well. Both of these have exponents of 1. Okay, that complex solution is just kind of embedded in this. Okay, so that means that at the square root of 2, there might be like a little that's about it. Okay. So the end behavior is going to help us with drawing this polynomial, right? Like it's going to actually help us sculpt the line. But will it ask, hey, as x approaches positive infinity, what's y doing? Probably. But all you're going to do is just look at the end. If they're both pointing up, it's going to be positive, right? All right, so here's kind of what we're building up to. The fundamental theorem of algebra. So the fundamental theorem is the degree of a function is equal to the total number of solutions of a function as long as duplicates are counted as separate solutions. Okay, so what does that actually mean? Okay, so down here, we've got state the number of zeros each polynomial has, and then find and graph the zeros. Okay, so if I have this function right here, I'm going to factor it and then solve for the zeros. Okay, what can I take out from both of these? What's the greatest common factor between these two numbers? 4 and 12 share what? 4 as a factor. Are there any x's that they share? Okay, how many can I take out from each one? I can take out 3, right? Because in this first one we got 4, and the second one we got 3, right? So we're going to take out an x to the third. So what is 4x to the fourth divided by 4x to the third? So 4x to the fourth divided by 4x to the third. We see that the 4's cancel. X to the fourth divided by x to the third gives me what? Okay, pause. Watch. If I have 4 x's and I have 3 x's in the bottom, these cancel out. What are we left with? 1. Okay, so we got x, and then we have 12x to the third divided by 4x to the third. What's 12 divided by 4? 3. And we have an x to the third and an x to the third. Those just cancel. Okay, so this is it in factored form. I need you guys to be comfortable with getting it to this point. Okay. Now we're going to take these, set them equal to 0, and then solve. So we're going to take 4x to the third, set it equal to 0, x plus 3, set it equal to 0. And when we solve, we'll get x equals -3. And when we divide by 4, and then take the cubic root, which we really haven't talked about much yet, we're going to get x equals 0. So we have solutions at x equals 0 and x equals -3. So x equals 0 and x equals -3. The factor and then solve for the solutions. Yeah, definitely gonna happen. Now, what kind of degree polynomial do we have? Okay, so let's try this again. What kind of degree polynomial do we have? So the 4th power, right? We know that the end behavior is going to be facing upwards because it's positive, right? Now, at x equals 0, what was my exponent? What was my exponent for my x equals 0? 3. That means that x equals 0, we're going to have a wiggle. So up here, we're going to have a wiggle. And at x equals -3, that's going to give us a cross because we have an exponent of 1, right? All right, so now we're going to actually sketch the line. We know that we're going to start upwards. We're going to come down, cross, and then we're going to wiggle through x equals 0. Okay, when you wiggle, what happens is you go up, kind of stay on that 0, and then continue back up. Looks like a wiggle. It would be slightly not correct. You want to definitely like make it apparent that it's like what's going on right here. Even if that means like you have to write out, hey, this is a wiggle. That makes sense? All right. Let's talk through this one. Okay, so back when we were doing quadratics, there's a couple different ways you can actually solve this out. You can either factor, or you can solve by taking the square root. Okay, so I'm going to show you what that means. So I'm going to add 50 to both sides. And this is going to give me 50 equals 2x squared. I'm going to divide by 2. And so you're going to get 25 equals x squared. When I take the square root, what's the square root of 25? 5. We're going to have a positive and negative version. So how many solutions do I have? 2. Remember, if there is a positive and a negative out front, there's going to be 2 solutions. So we're going to graph. So when I take the square root of 25, that gives me just positive 5. There's no negative underneath the radical. If there's negative underneath the radical, then we have an imaginary. Yep. Okay. So we're going to graph 5 and -5. And when we see that it's an even degree polynomial, we see that it is positive. So that means our end behavior is going to be both facing up. So we're going to come down, and then we're going to go back up. Okay. Both of these are going to be crosses because they have an exponent of 1. Okay. Are there any questions on how I graph that? Again, if you're not super solid in your factoring, I highly suggest going on to Khan Academy, watching a couple of videos, getting some practice in. Okay, at this point, we assume that you know how to factor. You need to know how to factor in order to do unit 4A, which is what the unit that we're going to end with this semester. Okay, so please make sure that you know how to factor. But we're just going to go with it. All right, so you should have had, just let me live my best life. Okay, so our solutions are 3 and 2. Okay. Okay, that's not bad. So we're going to graph 3 and 2. And then we know that it's positive and even. So we have an end behavior of like this. Okay. And my goofy line, I don't know why it was so weird, but you get the point. It's like a U, right? Okay. Just let me live. Okay. All right. Tomorrow, please don't think that you like don't have anything to do for school, because you do. Okay. You should have gotten this sheet right here. If you don't have it, you need to come grab it because you're going to need it for tomorrow. This is your performance final review. Okay. Your performance final is on Wednesday. You're going to come in. We're going to have like a short little like powwow, and then you're going to take your performance final. Yes, you have a performance final on Wednesday. Take that performance final. Okay. So with that being said, tomorrow I'm going to have a video posted on how to do these problems. Your performance final is 3 questions, but you pick 2 to do. So you could pick complex numbers, polynomials, or long division and synthetic division. Pick 2 to focus on tomorrow, and then crush it on Wednesday. Does that make sense? Yeah.